Hey, welcome back. We're starting our last chapter, chapter 12 today. That's our statistics chapter. So congratulations, you've almost made it to the end of this course. So yay, that's exciting for you and I both to see along this journey that we're coming kind of to a finale here. And anyway, I hope you like this chapter. So if you're following along with your note packet, we're going to talk about chapter 12 statistics notes, and you'll see some of the highlights. I want to just talk you through the intro here, just kind of reading along with you. That statistics is the art and science of gathering, analyzing, and making inferences from numerical data obtained in an experiment. Statistics is divided into two main branches. Descriptive statistics, that's one thing trying to say it sometimes too fast, statistics. Descriptive statistics is concerned with the collection, organization, and analysis of data. It's just the facts. Then the second branch would be the inferential statistics. This is probably more what you hear about when they make generalizations or predictions from the data. All right, probability and statistics are closely related. A statistician's interests lie in drawing the conclusions from the possible outcomes. So you may in another class or at another time have studied probability. So probability, finding the likelihood of events occurring, the general likelihoods of large samples, that's the probability side of it. So it is sort of tied in with statistics. And there is a chapter in your book if you want to learn more about that. But all we're going to be responsible for is the statistics chapter for us. All right, so some terms to be familiar with is population. When we say the population in statistics, we mean every single person that's under study. If we say the population of algebra students in America, that means we'd find every algebra student in the entire country and count those, which would be hard to do, right? To find an entire population of something. If you're studying, say, the entire population of America, that's a lot of people. And we'll talk about how it's hard to get a thorough population count of many things because it is so vast. So we take samples, which is the next term. A sampling is a subset of that population, which is more reasonable. What we usually do is a sampling that represents that population. It says in most experiments, observations of the entire population are not practical, like I mentioned, so therefore we use these samples. So typically you use these samples. The hope is you get a representative sample, though, that represents the whole population in all areas, if it's going to be a good sampling. So there's some notations. We use the Greek alphabet a lot in statistics for some reason, so you'll see that as you go along. So whenever we're measuring the mean of a sample, we use X. Actually, should have a bar over it. I probably didn't know where that key was to make a bar over that. So anyway, X bar for your mean. And then if it's the entire population, so this is, if it's a sample mean. And if it's the entire population, the symbol is mu, sort of like a U symbol. And if we're talking about the standard deviation, we'll call that SD for short, the standard deviation, you talk about that a lot in statistics. We'll be talking about calculating that ourselves as we get later into the chapter. But the symbol for a sample standard deviation is a small s, and for the population it's sigma, sort of like an O with a squiggle on it. In this book, we'll always assume we're working with a sample. Like I said, that's more typical what you see in statistics, a sample. So we'll be using this X bar and S. All right, so that's kind of an intro to the chapter. Then we'll talk about specifically 12.1. We talk about these sampling techniques. How do you get a good representative sampling from a population? Again, I'm going to read to you a little bit, so I hope that's okay in case you don't have your notes with you or if it's just easier to listen. But I'm going to read a little bit from your note packet here. It says, we hear statistics stated all the time that give a blanket description of what people think across the country. Of course, it would be impossible, I guess it's sort of possible, but we're going to say it'd be very improbable that you could poll every single American. For example, in political races, there is approximately 185 million eligible voters as of this writing. We usually know the winners of political races. You know how they call those winners on the TV? Sometimes month before we get there. The pollsters are out and they're kind of got the vibe of what the voters are going to determine on election day. A lot of times they call the election, or they're right about the election days, months, whatever before that the election even takes place. So they're pretty good at this, as figuring out exactly what's on the mind of the voter. So, but anyway, there's 185 million eligible voters as of this writing, so that would be hard to get a representative sample. But like I said, they've got this down to a science, and they're usually right on it. I've always been a big proponent of voting. I was Girl Scout leader. We did a Promise to Vote campaign and just really promoting voting as a way to get your feelings heard, your voice heard. So I'm a proponent of that. But, like I said in this, sometimes it's discouraging to even go vote when they've already kind of told you who's going to win. It's hard to go to the polls and cast your ballot when they're already telling you they've already determined this. So it's kind of anticlimactic, I guess, there. So that's kind of been a trend I've noticed in my lifetime, is the pollsters are so good at figuring out the winner that's almost kind of hard to go vote because they keep telling you who won already. But we saw kind of an anomaly the last presidential election, and I just note that here. It's been interesting. But you may want to Google a little more about that and see how many times and how far ahead they have called the election or been right about the election ahead. But we did have an unexpected one this past year, and I noted this has given the statistician and pollsters great concern because they did miss this one, so they're trying to figure out what happened. The goal is to get a random sample of the overall group that is representative of the whole. Statisticians must be tediously careful to ensure there is no bias. We're trying to avoid bias, right? An unbiased sample is one that is a small replica of the entire population with regard to race, income, education, sex, your religion, your politics, your age, and on and on and on. Anything that would divide us into different categories and affect a group as a whole. All right, we're going to study in this class some basic sampling techniques. But as always, we just scratch the surface of topics in this class. It's kind of a topical study, and we just hopefully pique your interest in any of these to know enough about it to where you've got a base to grow on. If you wanted to know more, you could go fully into that topic and study it deeper. But we're just scratching the surface a little bit, so just some basic foundational things. So we're going to study 5 types of sampling techniques, and there will be others, but the 5 we're responsible for in this class would be: number 1, random sampling. A true random sampling, if there would be no strata like religion, sex, politics, and all that to go on, if it's just like in the lottery drawings, they just have those little balls that bounce up and you get a random one pops up to give you a number. So a true random sample is hard to get, if it's using that technique, if it deals with people and we've got more complications. But if they're just these little random balls that pop up, out of the machine, like in the lottery drawings, that just create numbers. Also, there's apps on your phone if you're playing maybe some sort of game where you need a randomized number. A lot of phone apps will do that, so they can randomize the numbers for you. So a true random thing, it says drawn in such a way that each time an item is selected, each item in the population has an equal chance of being drawn. There's no biases going on. It just pop up those numbers like in lottery drawings and random number generators. The second one is systematic sampling. And when a sample is obtained by drawing like every nth item on a list or in a production line, maybe for quality control, they're running, the potato chips or the cornflakes. Let's go with Kellogg's cornflakes. So they're doing Kellogg's cornflakes and they're running the assembly line, and a quality control person will pick the every 100th box off the line and weigh it to see if it's coming out as the standard should be, to weigh how many ounces is in that box. So maybe you're randomly sampling, but it's a systematic sampling. It's still a sampling technique to try to get an unbiased result. So every nth item, like every 100th box of cornflakes, that would be an example of that. Or if you get a telephone book and go down every 20th person, you're going to call that person and do a survey. So that would be a systematic way, every nth person. Number 3, cluster sampling. It's sometimes referred to as area sampling on a geographical base. So when you're doing your homework, if you kind of hear they're surveying people in Grayson or they're surveying people in Lexington, if it sounds like it's on a geographical cluster, they call it cluster sampling based on where people live. So that's, for example, a survey of a city block or a survey of a township, state, etc. It's more geographically based. That'll be your clue to know it's cluster sampling. Number 4, stratified sampling. Stratified sampling, things that we call strata, are things that divide the population into parts, like I mentioned earlier: race, religion, sex, politics, color of your eyes, whatever kind of strata, some identifying trait that you have. That's stratified sampling. This is especially important in the political races, like I mentioned earlier. The pulse of different strata or their characteristic is studied, such as your race, religion, sex, sexual orientation, socioeconomic status. If you have brown eyes, I don't know, anything that you can come up that kind of divides you. Number 5, and the last one we're responsible for, is convenience sampling. And sometimes this is all you've got. A researcher is trying to study something and they've just got to find people on the street and just talk to the next person that comes through that door. So that's convenience sampling. It says, I'm going to talk to the next 5 people that walk through my door, or you're at Kroger's, you're going to survey people that are coming through the door at Kroger's, just whoever is available, whoever is convenient. That's called a convenient sampling. All right, the next topic we're going to talk about that deals with section 12.1 would be the misuses of statistics. It says, do numbers lie? You might have heard the thing that numbers don't lie, right? And I'm going to go with that. I'm going to say, yeah, numbers don't lie. It's the statisticians that may misinterpret them or make them say what they're trying to say, so how they kind of target the numbers. But the numbers, pure numbers, really can't lie, right? It's how we interpret it. So that makes us responsible for reading the data closely to see exactly what do the numbers say. So numbers are foundational to all statistical information. The lie occurs when either intentionally or carelessly a number is used in such a way that it leads to an unjustified or incorrect conclusion. So numbers may not lie, but they can be manipulated and misinterpreted. This section should help us recognize when statistical information is being manipulated or misinterpreted. It should also help us see the many values and uses of statistics, because they really are everywhere in our society, charts and graphs, and we're advertised to in different ways with these statistics. So vague or ambiguous words can lead to statistics misuses. The word average is such a culprit. Do you know that there are at least 4 types of averages? The mean, which is probably what most people think of, where you add each value and divide by the number of values, and we're going to talk more about that later. But that's probably the one that most people infer you mean when you say the word average, but there's actually 4 types of averages. So there's the mean, where you add and divide by how many are present. There's the mode, which means the most commonly used number. The median, which is the middle of the data, like if you rank them from smallest to largest, it'd be the one in the middle, that's the median. And there's the mid-range. Mid-range is where you take the 2 extremes and average them. Or I shouldn't say average, where you take the mean of the 2 extremes. So, and again, we'll talk about that more later. So if you were inquiring about job choices and a company states its average pay is $20 per hour, there's lots of ways to interpret that. This could mean that any of those 4 types of averages. Maybe it's $20 is the most common pay, is the mode. Or maybe if there's an extreme value in there, if the CEO is making $1 million and we add that in with our averaging, it could really affect the mean and the mid-range, especially extreme values really affect your mean and mid-range, because those are based on adding all the numbers together and dividing for mean, and then adding the 2 extremes, which would take the $1 million person and the person making minimum wage, and average those. So it would be very misleading. So maybe most people are making $9 an hour, but it seems like the average is 20 if they're stating the mode, or if they did mid-range and you've got an extreme CEO value or something in it. So you need to inquire deeper about that if you really want to know. So this said, we need to be more savvy consumers and know what questions to ask to get to that deeper meaning. Another example of that on the next page is this is why a company may advertise that their average salary is $45,000 a year, but the union says, "Hey, it's a $40,000. We need to get a raise here." So they could both be correct because both of those could be averages computed with those different types of average I mentioned. But no, everyone will use the number that pleads their case the best, that makes them look the best. So that's sort of the thing I said about numbers don't lie, but we can use numbers to our advantage, kind of make our case best for us.